In this video, we will compare cosine and negative cosine using the Taylor series expansion. We begin with the dataset of cosine. Our formula: cosine of the x values 0 to 6. And the negative side, negative cosine. This is our formula: cosine of the x values 0 to 6. This time we factor in the negative sign. And the Taylor series expansion, it is the summation of a times x to the power 2n, where the value of n is 0 to infinity. 14 is good enough. And the value of a is our formula: minus 1 raised to the power the quantity n plus k, n plus k. This is our k. Divided by, our denominator has two parts. The first part, double factorial. So double factorial to n, 2 times n. That's the first part. The second part, double factorial to n minus 1. So double factorial to n minus 1, 2 times n minus 1. And we correct this error, where value of k is data validation, list of items 0 or 1. 0 or 1. And save. 0 or 1. We correct this error. So if n equals 0, if n equals 0, then it is negative 1 raised to the power k. Otherwise, calculate. So at k equals 0, you have this value. At k equals 1, you have this value. The signs are alternating. Now we continue with the series sum. So our formula: series sum of the x values raised to the power, or raised to the power 2n. 2n start from 0, incremented by 2, and the coefficient, it will be this range. That's our a. And we chart this. Insert chart. And we use scatter chart. And column A as label. For the series, we show the trend line. The type, polynomial. The degree, 6. For the label, use the equation. For the legend, position at the bottom. We don't need a title because we need a space. And here's our trend line and polynomial of positive cosine and negative cosine and their expansion. We modify our chart to emphasize the points. So customize the series, the point size will be maximum. Except for the expansion, the point size will be none. But its line thickness will be maximum. Now we can toggle this 0 or 1. We calculate this polynomial regression coefficient using LINEST. To do that, we complete the LINEST matrix, starting with the power, transpose, 0 to 6. And the coefficients are the elements of the matrix. Array formula of the x values 0 raised to the power 0 to 6. Now we calculate the polynomial regression coefficient. So LINEST data y, and data x. LINEST, data y, and data x. And finally, the negative cosine. LINEST, data y, and data x. And compare the polynomial, the coefficients with the chart. So starting with x to the 0, 1, 1, minus 1. For coefficient of x, minus 0.0555 plus 0.0555. X to the x squared, minus 0.354, positive 0.354. X cubed, minus 0.147, positive 0.147. X to the fourth, 0.117, minus 0.117. X to the fifth, minus 0.0201, plus 0.0201. X to the sixth, 1.07 times 10 to the minus 3, negative 1.07 times 10 to the negative 3. If you toggle this to 1, these values are exactly the same. And their data sets are almost the same, because this is only an approximation, but they're close. If k equals 0, it is positive cosine. These values are the same, almost the same. There's an error here. And their polynomial regression coefficients are also the same. This completes the use of the SERIESSUM function, the LINEST function, to generate the polynomials, the Taylor polynomials of cosine and negative cosine.